This first question is relatively easy. It's asking for what is the molecular formula of compound D, and if we could just highlight compound D over here, it's a simple case of just simply counting how many atoms of each type we have. So if you look at the carbons first, we've got 1, 2, 3, 4, and then the hydrogens we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this particular case, the answer as is listed over here would be C4H10. The next question is asking for what is the empirical formula of compound C. So if we just scroll to C, the very first thing I would do with this type of question is to actually look at the molecular formula of it first. So let's have a look at how many carbons we have. The carbons we have, let's start off with C, are 1, 2, 3, 4, so C4. The hydrogens we have are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's H10. And finally we have 2 oxygen molecules, one here, O2. And then it's a simple case of cancelling down to the simplest ratio, which will give us C2H5O. One common mistake that students have been making is they've been showing this as C2H4OH, and that is something that you must absolutely avoid, because this over here, OH, is now part of a structural formula, not an empirical formula. So at all costs, do not show any OH groups inside an empirical formula. Part 3 is now asking for which 2 compounds are structural isomers of each other, and if we scroll back up to the list, we're looking for 2 compounds which have got exactly the same molecular formula but different arrangements of atoms in space. And the correct answer here, if I can highlight that, if we look at B, which is this over here, and if we look at E over here, we have 1, 2, 3, 4 atoms of this carbon. Let's just highlight those. 1, 2, 3, 4. So the molecular formula here is C4. Hydrogens we've got 10, and we have 1 oxygen. And if you look at the molecule E over here, we have exactly the same 4 carbon atoms, and we have 10 hydrogens and 1 oxygen atom. Both of these have exactly the same molecular formula as we can see here and here, which means that the isomer part is coming from the fact that we have an OH at the end over here but not at the end over here. So different arrangements of atoms in space but the same molecular formula, therefore B and E are isomers. And last of all, it's asking for which 2 compounds are cis and trans isomers of each other. Cis and trans, remember, is a type of EZ isomerism. And again, if we look at the list, what we need to look for is, first of all, which 2 molecules have got a carbon-carbon double bond. And the only 2 molecules which do have a carbon-carbon double bond are listed as A and F. Now if you look closely over here, what you will see is that we have a methyl group at the top and bottom in this particular instance, whereas over here we have a methyl group bottom and bottom. So we have the cis-trans or EZ isomer, and do recall that if you have a Z isomer, which would be this one over here, you'll have both the heavy groups on one side, whereas if you have an E isomer, you have a heavy group at the top and at the bottom. And question C, as I talked about previously, has got alcohol C inside it. Alcohol C is this one over here. Now again, similar to what I described earlier, we will remove OH and an H, as well as OH from this side and an H from over here. So water will be removed from both ends of the molecule, so we will actually form a double bond here and here. In part B of the question, we're asked for a balanced equation to complete the reaction for the dehydration of an alcohol, and we can clearly see we do have an alcohol because of the OH group over here. The key to answering this question is realizing the fact that we have an OH group here and we are ultimately going to lose water, so we need to combine with this OH group another H, which can either come from the left or the right of where the original OH group is. So for argument's sake, I will just eliminate the H from over here, and if by eliminating H2O from this location here, I end up with an alkene, as you can see here. And for clarity, I will just draw out the actual displayed formula, which will look something like this. So the first CH3 is unaffected, the CH2 is also unaffected, the next carbon is affected, so you don't have the OH anymore over here, neither do you have the H over here. We have a double bond here now, and we have two hydrogens at the end to give us a molecule over here which is but1ene. Equally, if we had removed water from OH and OH over here, the double bond would have been in this location to give us but2ene. Question C is talking about compound C. And what we'll end up with is a molecule which has got two double bonds inside it now, and because the double bond is started on position 1 and 3, it will be called buta-1,3-diene. And you should be able to see quite clearly that the double bond starts on position 1, and then the second double bond starts on position 3. Hence the name 1,3-diene, because you have two double bonds. Question 2 is a relatively straightforward question talking about free radical substitution. And in this particular case, we're asked to write an equation for the reaction between methane and bromine to make bromomethane and hydrogen bromide. Why I think it's a particularly easy equation is you are given the reagents, methane and bromine, and you're also given the products, which are bromomethane and hydrogen bromide. In essence, they've given you the word equation here, and we are asked to actually complete a balanced chemical equation, which is just taking into account the words here, putting the formulas in, and then bromomethane is here and hydrogen bromide is over here. And as we discussed in class, free radical substitutions normally end up with more than one hydrogen being replaced. So in this particular case, we removed one hydrogen to replace it with a bromine. Equally, we could have removed two hydrogens to form dibromomethane, equally tribromomethane, by replacing three of these hydrogens or removing all of these hydrogens to form tetrabromomethane. The last part of the homework is something that students generally find slightly difficult, mainly because they see a blank page and quite a few marks and they think, oh my god, what do we write here? It's actually not that bad. Close attention needs to be paid to exactly what the question has been asking for. They're asking for the description of the mechanism, which in reality means drawing out the equations, and then suggesting at the end why a small amount of ethane is formed. The very first step is you'll have to talk about the bromine molecule being broken down into two bromine radicals, or actually calling it homolytic fission of bromine, which means equal bond splitting of the bromine molecule, followed by the first propagation step listed over here. The radical generated over here is using the second step of propagation to regenerate the bromine radical, which will follow back here. Once you have that done, you can actually talk about the termination of the radicals. So you can have a bromine radical here combining with a methyl radical to form bromomethane, or two bromine radicals coming together. And again, you can have two methyl radicals coming together to form a molecule of ethane, as was asked in the first part of the question. Quality of written communication, two names of the steps, for example initiation and propagation, with their correct equations, and if you have all three steps, initiation, propagation and termination, correctly labelled, then you'd have 2 marks for the quality of written communication.